Let's start with the today's Google Classroom. That is a physical chemistry from the paper number 8. And today's unit is thermodynamic first. So today's topic we have to discuss are work done in a reversible and irreversible processes. Before to start with work done in reversible and irreversible processes, we just recap the introduction about the thermodynamics. What is the thermodynamics? So thermodynamics is a branch of the physics that deals with heat, temperature, and their relations to the energy, work, radiation, and the properties of the matter. The behavior of these quantities is governed by the four laws of the thermodynamics, which convey the quantitative description using measurable microscopic physical quantities, but may be explained in terms of microscopic constituents by the statistical mechanics. Thermodynamics applies to the wide variety of topics in science and engineering, especially physical chemistry and the chemical engineering and the mechanical engineering, but also in the fields as complex as meteorology. So in short, thermodynamics is a branch of physics. It deals with only the heat and the temperature and the relation between the heat and temperature to the energy, work, radiation, and the properties of the matter. So let's see what is the work done in a reversible and the irreversible processes. So thermodynamics is a reversible process. Is a process whose direction can be returned to its original position by inducing infinitesimal changes to the some property of a system via its surroundings. Throughout the entire reversible process, the system is in thermodynamic equilibrium with its surroundings, having been reversed. It leaves no change in either system or the surroundings, since it would take an infinite amount of the time for the reversible process to finish. Perfectly reversible processes are impossible. However, if the system undergoing the changes responds much faster than the applied change, deviation from reversibility may be negligible. Or in a reversible cycle, or the cyclic reversible process, the system and its surroundings will be returned to their original states if one half cycle is polluted by the other half cycles. Then thermodynamic process can be carried out in one two ways, that is reversible or irreversibly. Reversibility means the reaction operates continuously at quasi-equilibrium. In an identical thermodynamically reversible process, the energy from the work performed or by the system would be maximized, and that from the heat would be zero. However, heat cannot fully be converted to the work and will always be lost to some degree. This is true only in case of the cycle. In case of an ideal process, heat can be completely converted into the work. The isothermal expansion of the ideal gas in a piston cylinder arrangement, the phenomenon of maximized work and minimized heat can be visualized on the pressure volume graph as the area beneath equilibrium curve representing work done in order to maximize the work. One must follow the equilibrium curve precisely. Irreversible processes, on the other hand, are the result of the straying away from the curve, therefore the decreasing the amount of the overall work done in an irreversible process can be described in thermodynamic process that departs from the equilibrium. So the alternative definition for this reversible and irreversible process, it is given, that is, after it has been taken place can be the reverse, and when reverse turn system and its surroundings to their initial states. thermodynamic terms of process taking place would refer to this transition from the one to the another. So these reversible and the irreversible processes are explained by using this ideal Carnot cycle or the PV diagram. So by using this ideal Carnot cycle, we can definitely give idea about the reversible and the irreversible processes. Thank you.